everyone, I'm teacher Zaira, your science mentor for today's video. In this video, you will learn one of the most significant processes in the ecosystem, which is nutrient cycling. You will learn the functions, types, and importance of nutrient cycling in the ecosystem, and the human activities that affects the nutrient cycle and its function. So sit back, relax, and listen as I'll show to you the process called nutrient cycling. Let's start! All organisms, living and non-living organisms, depend on one another. Any given ecosystem requires a state of equilibrium to function adequately. But what makes it function? It's because of the process nutrient cycle. Let's first define what is nutrient cycle. The nutrient cycle describes the use, movement, and recycling of nutrients in the environment. In simpler terms, the nutrient cycle is nature's recycling system, overseeing how nutrients move from physical environment into living organisms, and then back into the physical environment to start the cycle over again. It is the movement and exchange of organic and inorganic matter through the production cycle of living matter. Why nutrient cycle is important? Nutrient cycling allows matter to convert to form which can be used by different organisms. Take nitrogen for example. This element is essential to plants. However, plants are only able to absorb it in two forms, nitrate and ammonium. So plant growth would be significantly limited without the modification of nitrogen into these forms. Nutrient cycling allows elements to be transferred to more accessible locations such as the soil. This is critical since many elements are typically found in areas most living organisms do not have access to. For example, nitrogen is usually found in the atmosphere rather than in the soil. Nutrient cycles allow for the storage of elements, which is important because certain organisms only require a small quantity of a particular nutrient to sustain life. In a nutrient cycle, elements remain stored in their natural reservoirs and are only released to different organisms in an appropriate quantity. There are 18 essential elements needed by plants and animals on Earth, and because life needs to continue from year to year, so must the availability of these nutrients. Of the 18 essential nutrients, some are classed as macronutrients because the plants and animals need them in fairly large quantities. Others are classed as micronutrients and are needed in much smaller quantities. Over the millions of years that plants, animals, and men have been on the planet, there has been ongoing adjustment by plants and animals in a particular period to changing soil and climatic conditions. In each climatic period, there has generally been a balance created between the nutrient needs of the vegetation and animals and the ability of the soil to supply it. At the heart of this is nutrient cycling. The cycling of nutrients is essential for maintaining plant growth and ultimately the sustenance of plants and animals. There are four important types of nutrient cycling: the water cycle or hydrologic cycle, the carbon cycle, the nitrogen cycle, and the oxygen cycle. The producers of an ecosystem take several basis inorganic nutrients from their non-living environment. These materials get transformed into the biomass of the producers. Then they are utilized by the consumer population and are ultimately returned to the environment with the help of the reducers and decomposers. Let's start with the water cycle or hydrologic cycle. In this cycle, water from the transpiring plants, oceans, rivers, and lakes evaporates into the atmosphere. This water vapor subsequently cool and condense to form clouds and water. And water returns to the earth as rain and snow. The second one is carbon cycle. Most of the carbon dioxide enters the living world through photosynthesis. The organic compounds synthesized are passed from the producers or green plants to the consumers or herbivores and carnivores. During respiration, plants and animals release carbon back to the surrounding medium as carbon dioxide. The dead bodies of plants and animals as well as the body waste with accumulate carbon compounds are decomposed by microorganisms to release carbon dioxide. The third is nitrogen cycle. Nitrogen of the atmosphere is the elemental form and cannot be used as such by living organisms. It has to be fixed, combined with other elements such as hydrogen, carbon, or oxygen, to become usable for the green plants. Nitrogen is continuously entering into the air by the action of the nitrifying bacteria and returning to the cycle through the action of lightning and electrification. The fourth one is oxygen cycle. Oxygen required for respiration in plants and animals enters the body directly from the surrounding medium, air or water. Oxygen returns to the surroundings in the form of carbon dioxide or water. It also enters the plant body as carbon dioxide and water during photosynthesis and is released in the form of molecular oxygen as a byproduct in the same process for use in respiration. Thus, the cycle is completed. Ecosystem is a functional system which is in a balanced condition and self-sufficient and self-regulating. A balanced ecosystem is essential for the survival of all living organisms. Organisms at each trophic level in a food chain are preyed upon by an organism at the next higher trophic level. Nutrients from soil are taken up by plants, which are consumed by humans or animals, and excreted again by them, or they are released back into the environment when organisms die. For example, when plants lose their leaves. Microorganisms in the soil break this matter down, and again, make nutrients available in their mineral form, which makes it possible for plants to take them up again. Furthermore, agriculture also influences the nutrient cycle in another way. Agriculture accelerates land erosion because plowing and tilling disturb and expose the soil. So more nutrients drains away with runoff, and flood control contributes to disrupting the natural nutrient cycle. Typically, river floods would redistribute nutrient-rich sediments to lower lands where it is again available for ecosystem. Instead, dams trap sediment or embankments confine it to the river until it washes out to the sea. So too much nutrients from eroded soil and from human and animal waste ends up in lakes and oceans where it spars massive and controlled blooms of algae. Once they die and fall to the bottom, their decay starves other organisms of oxygen, creating dead zones, and contributing to the depletion of fisheries. These human-induced alterations in the nutrient cycles lead to an imbalance in the availability of nutrients, whose consequences in particular with regard to water are grave. Number 1. Depletion of soils. The accumulation of nutrients in the seas means that they are depleted elsewhere, to a large extent from soils. This leads to the fact many of the fruit and vegetables that animals and humans are consuming essentially contain less nutrients, minerals, and vitamins. Applying more artificial fertilizers is not the solution. It is energy and cost intensive. It can lead to salinization, and because artificial fertilizers, which are mainly based on the three main components, nitrogen, phosphorus, and potassium, are essentially incomplete. Furthermore, soils that do not contain adequate amounts of organic material are not able to absorb much of the nutrients added and also have a low water holding capacity. Number 2. Depletion of nutrient sources. While nitrogen can be gained from the air, it is an energy-intensive process that is mainly based on the use of fossil fuels. Other components of artificial fertilizer are based on fossil resources, such as phosphorus. The amount that is easily mined is limited. If these easily mineable resources are depleted, this means that phosphorus prices will increase drastically. Number 4. Affordability and food security. Fertilizers are bound to world market prices, which are already substantially high for many farmers from developing countries. An increase in price is to be expected in the case of phosphorus, will make them unavailable for many farmers. This may make agricultural products, especially in developing countries, more expensive and thus lead to a decreased food security. Number 5. Eutrophication of waterways and dead zones. Fertilizer runoff and wastewater discharge contribute to eutrophication, uncontrolled blooms of algae in river, lakes, and oceans, feeding on nitrogen and phosphorus from fertilizers. When they die, their decomposition depletes the water oxygen and slowly chokes aquatic life, producing dead zones. As a human being, how can we make a change? Changes in nutrient cycling can indicate changes in the ecosystem function. As humans, we are responsible in maintaining the quality of nutrient cycle, generating actions that can bring significant change to the environment. Nutrient cycling is one of the most important processes to sustain plant growth, agriculture, and thus humanity. So let's start saving and conserving the ecosystem. And that ends our discussion. I hope that you enjoy and learn something from the video. Again, I'm Teacher Zaira, your science mentor for today's episode. Thank you for watching.